Imagine gazing up at the night sky, a black velvet canvas speckled with stars, galaxies, and the silent promise of infinity. Now, imagine this. What if, out there beyond the reach of our most powerful telescopes, the rules of nature itself began to bend and twist in unfamiliar ways? What if gravity was stronger, weaker, or didn't exist at all? What if light traveled not in straight lines but in spirals? Or if time moved differently from galaxy to galaxy? What if every shimmering island of stars we see in the cosmos obeyed its own unique laws of physics, laws that would render our understanding of reality utterly obsolete the moment we stepped beyond our galactic borders? It's a scenario that feels like pure science fiction, but it rests on a foundation of genuine scientific speculation. To understand why, we must first consider how the universe currently behaves, or at least, how we believe it behaves. The universe, as far as we can observe, seems to operate with a uniform set of rules. Whether we're studying a black hole in the center of a distant elliptical galaxy or tracking the orbit of a tiny moon around Saturn, the same four fundamental forces apply: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. These forces are governed by fundamental constants, fixed numerical values like the speed of light, the charge of the electron, and the gravitational constant. They're so deeply woven into the fabric of our physical reality that without them, atoms wouldn't hold together, stars wouldn't shine, and life as we know it couldn't exist. But here's the twist. Modern theoretical physics has begun to suggest that these constants may not be as constant as we once thought. In fact, they may not be fundamental at all. They could be emergent properties, shaped by conditions in the early universe or determined by hidden aspects of reality we haven't yet uncovered. This is where ideas like string theory and the multiverse hypothesis enter the conversation. String theory, for instance, proposes that all particles are actually tiny vibrating strings, and the way they vibrate determines what type of particle they are. But here's the kicker. The way these strings vibrate depends on the geometry of the universe's extra dimensions, dimensions that we can't see or experience directly. The result? A vast landscape of possible universes, potentially as many as 10 to the power of 500, with each one having its own unique configuration of particles, forces, and physical laws. This concept is often referred to as the string theory landscape. It's a staggering idea. Imagine a reality not with one universe, but with a virtually infinite number of universes, each bubbling into existence during the early moments of cosmic inflation, a rapid expansion thought to have occurred just a fraction of a second after the Big Bang. Each of these pocket universes could have its own version of physics. Some might be cold, empty voids. Others might be seething with unstable energy. A few, just a few, might be stable and life-permitting like ours. But what if this concept doesn't just apply to separate universes? What if the idea of variable laws of physics isn't limited to distant multiverses? What if galaxies within our very own universe could exhibit subtle or even drastic differences in their fundamental rules? Think about it. We've only observed a tiny sliver of the universe. The observable cosmos stretches about 93 billion light-years across, but that's just what we can see. The rest, possibly infinitely more, remains forever hidden beyond the cosmic horizon. And in those unreachable regions, the physical constants could be different due to environmental variations set during inflation. If this is the case, then our assumption of uniformity across all galaxies could be tragically naive. Consider what a universe like that might look like. In one galaxy, gravity might be stronger, stars burn hotter and faster, massive black holes form easily, and galaxies tear themselves apart before life can even emerge. In another, gravity might be so weak that gas clouds never collapse into stars, and entire galaxies drift as loose collections of dark matter and primordial hydrogen. In yet another, the strong nuclear force might be slightly different, resulting in a chemistry so alien that DNA, water, and even carbon couldn't exist. Some galaxies might be silent voids filled with exotic matter. Others might explode into being and vanish in moments. And perhaps, just perhaps, One galaxy out of a trillion would have laws fine-tuned enough to support complexity, stability, and eventually, consciousness. Now here's where the story becomes even more compelling. Observational cosmology has provided us with data that seems remarkably consistent across vast distances. The cosmic microwave background, the faint afterglow of the Big Bang, shows only tiny fluctuations in temperature, no more than a few parts in 100,000. That uniformity gives us a sense of security, that physics is the same everywhere. But what if that's just the illusion of limited perspective? We've only had 100 years of astronomical observations. Our data, while vast, is still confined to a very narrow view. If differences in physical laws are subtle, or emerge only in remote corners of distant galaxies, we may have simply not looked long enough, far enough, or deeply enough to notice them. And that leads us to one of the most mind-bending questions of all. Could we ever detect such variations? And if we could, what would that mean for our place in the cosmos? Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the mysteries of the universe, hit subscribe. It's free and it helps us grow this community together. As we move forward in this series, we'll explore the consequences of variable laws of physics in greater depth, how such differences would alter everything from the birth of stars to the evolution of intelligent life, and whether there's any way to prove or disprove this cosmic speculation. Buckle up, because what lies ahead is not just a journey through space, but a reimagining of reality itself. So let's say the impossible becomes possible. Imagine we develop a telescope, perhaps the successor to the JWST, capable of peering across vast stretches of space and time with such precision that we detect something odd. In one distant galaxy, starlight seems to behave differently. Its redshift doesn't match predictions. The spectral lines from elements appear slightly displaced, not just by motion or gravity, but by something deeper, something intrinsic. After ruling out every known explanation, we arrive at a staggering conclusion. The fine structure constant, a fundamental parameter that governs how light interacts with matter, is ever so slightly different in that galaxy. The implications are profound. We are no longer dealing with a universe governed by a single set of rules, but a patchwork cosmos where each region may tell its own version of reality's story. But before we fall headfirst into science fiction, let's ground ourselves in what we actually know and what we suspect. First, the fine structure constant is a great example. It's a dimensionless number, about 1 over 137, that dictates the strength of electromagnetic interaction. If it were just a few percent stronger or weaker, chemistry as we know it would break down. Molecules wouldn't form properly. Stars wouldn't fuse hydrogen efficiently. Life, at least in any familiar form, would be unlikely. Yet over the past 2 decades, a few astronomical studies, controversial but persistent, have hinted at the possibility that this constant might vary slightly across the universe. In 2010, a team analyzing the absorption spectra of quasars suggested a dipole variation. In one direction, the fine structure constant appeared slightly smaller, in the opposite direction, slightly larger. The variation was minuscule, on the order of parts per million, but if true, it could be the first whisper that the laws of physics aren't universal after all. Now imagine the cause of this variance isn't random. What if during the inflationary epoch of the early universe, quantum fluctuations imprinted regions of space with slightly different vacuum states? In those vacuum states, the values of physical constants locked in differently, creating subtle but permanent changes in how each patch of the cosmos operates. In most regions, the constants were lethal to complexity. No stars, no atoms, just entropy. But in a few pockets, like ours, the conditions were just right. These regions didn't need to be fully separate universes. They could be vast galactic zones, perhaps separated by billions of light years, each silently obeying its own version of physics. Let's play this out. Suppose we could travel to such a galaxy. As our spacecraft enters its domain, we begin noticing anomalies. Gravitational forces behave oddly. Perhaps they weaken with distance more rapidly than they do in our own galaxy, suggesting a different space-time curvature. Stars orbit their centers in a way that defies our understanding of dark matter. Maybe there's more baryonic matter, or perhaps dark matter behaves differently entirely. The light from the stars has a different hue, not because of dust or speed, but because photons themselves interact differently with electrons. Time itself might pass more quickly or slowly, as measured by atomic clocks brought from Earth. Our ship's systems, reliant on finely tuned interactions between electricity and magnetism, begin to glitch, unable to adapt to the new rules of the game. If this sounds familiar, it's because the notion has appeared in countless works of speculative fiction. In Star Trek, for instance, some alien worlds have environmental anomalies that challenge the crew's scientific models. But those stories often gloss over the sheer horror and wonder such discoveries would bring. It wouldn't just be a curious puzzle for physicists, it would be an existential revelation. Imagine being the crew member who confirms the laws of physics aren't fixed. Imagine the scientific and philosophical fallout. Are we just lucky, chosen? Is our physics local or global? Suddenly, truth becomes something contingent, regional. The foundation of objectivity in science, based on universal reproducibility, would shake. To wrestle with this idea, scientists turn to the anthropic principle. It states essentially that we observe the universe the way it is because we exist to observe it. It's not that the universe was designed for life. It's that only those universes or regions compatible with life could ever be noticed by intelligent beings. In other words, the vast majority of the cosmos could be deadly, disordered, chaotic, yet we wouldn't know it. We're in the exception, not the rule. But here's the nuance. If different galaxies have slightly different laws of physics, the anthropic principle becomes even more intriguing. Our universe wouldn't just be fine-tuned. It might be part of a sprawling cosmic roulette wheel, where every galaxy spins with a different set of initial conditions, and we happen to land on the winning numbers. There's also a more disturbing possibility. What if our own physics isn't as stable as we think? What if constants can evolve, shift slowly over cosmic time? Some physicists have proposed that the vacuum of space is not perfectly stable. A false vacuum, an unstable state, might decay into a lower energy true vacuum at any moment, rewriting the laws of physics at the speed of light. Everything we know would unravel. It's called vacuum decay, and while there's no immediate sign of danger, the mathematics allows for it. What's truly eerie is the idea that this has already happened in other regions of the universe. We just haven't seen the wall of rewriting physics reach us. Yet these ideas might sound terrifying, but they also reveal something beautiful. The deeper we dig, the more we realize how fragile and precious our corner of the universe is. The very fact that you're watching this video, that atoms in your brain are firing in recognizable patterns, that you can understand language and reflect on your place in the cosmos, that's extraordinary. Out of a near-infinite range of possible realities, you're here in this one, contemplating the others. And that brings us to the next question. Could life exist under different physical laws? If the fundamental forces or constants were altered, would life still find a way? Or would all the other galaxies be silent, sterile tombs? Let's push this thought experiment further. We've now accepted the idea, at least hypothetically, that galaxies could exist under different physical laws. But here's the real question. What happens to life in a universe like that? Does biology adapt to alien physics? Could intelligence evolve in a galaxy where gravity is 20 times stronger, or where electromagnetism behaves unpredictably? Or are we, in our precious little corner of the cosmos, truly alone, not just by distance, but by design? To understand the stakes, we first need to revisit the idea of fine-tuning. Scientists have long marveled at how delicately balanced the conditions of our universe seem to be. Change the strength of gravity by even the tiniest fraction, and stars either collapse too quickly or fail to form altogether. Alter the mass of the proton by a few percent, and atoms become unstable. Tweak the strong nuclear force, and carbon, the essential building block of life, is never created inside stars. These aren't wide margins. They're razor-thin thresholds that separate a universe teeming with complexity from one that's cold, featureless, and dead. Now imagine a galaxy where these variables are just outside those thresholds. Maybe hydrogen is unstable. Maybe fusion never happens, and stars don't shine. Or perhaps stars form, but burn so fast and erratically that planets never coalesce into stable orbits. In these galaxies, life doesn't merely struggle. It never gets a chance to begin. There are no biochemistries, no DNA, no consciousness. Just matter adrift in silence. But that doesn't mean all of these altered galaxies are lifeless. The question becomes, are there versions of physics that are different but still compatible with life? Let's explore one possibility. Suppose in some distant galaxy, the electromagnetic force is slightly stronger. This would compress atomic orbitals, making atoms smaller and chemical reactions more rapid. Water, if it exists, might boil at a different temperature. Molecules might form with entirely different bonding patterns. DNA, at least as we know it, might be impossible, but that doesn't rule out some form of information-carrying molecule, maybe a different backbone, a silicon-based spiral instead of a carbon one. Maybe life there exists in a temperature range wildly different from ours, based on exotic solvents like ammonia or methane. The rules of biology might be unfamiliar, but not unthinkable. Astrobiologists often grapple with this idea in a more earthbound context. On our own planet, extremophiles, organisms that thrive in boiling acid, frozen methane lakes, or near volcanic vents, defy our assumptions about habitability. Life finds a way, even in places where the known rules of biology begin to bend. Now stretch that thinking to a cosmic scale. What if, in a galaxy governed by slightly different physics, life didn't emerge on planets at all? What if it formed inside the dense magnetic fields of a gas giant, or within the corona of a cooler, more stable star? What if, instead of carbon-based chemistry, consciousness arose from plasma interactions or photonic lattices formed in crystal-like structures floating in the vacuum? Science fiction has offered daring visions of this. Arthur C. Clarke imagined beings of pure energy that lived in the rings of Saturn. In Liu Cixin's The Three-Body Problem, an alien civilization evolves under chaotic stellar conditions, developing physics so alien it warps our understanding of reality. While these are stories, they're grounded in a very real question. Is our version of physics the only path to complexity, or merely one of many? Now let's consider the opposite extreme. What if some galaxies obey laws that are too strange for life? Consider a galaxy where the speed of light is dramatically slower, say, only a few thousand kilometers per second. Light would take hours to cross a planetary system, making energy transfer from stars to planets incredibly inefficient. Evolution might crawl at a glacial pace, assuming it can happen at all. Or flip the scenario. Light is much faster, and causality becomes impossible to maintain. Events become unpredictable. Particles pop in and out of existence too quickly for stable matter to form. Time itself might stretch and compress erratically, like ripples in an unstable pond. These galaxies wouldn't just be inhospitable, they'd be fundamentally chaotic. Then there's the deeper question of consciousness. Could an intelligent species evolve to understand its universe if the rules keep changing? Our brains work because they can form patterns. We recognize cause and effect. We predict the outcome of dropping a stone or throwing a spear. But in a universe where the constants vary from one star system to the next, or shift over time, logic becomes unreliable. Intelligence might still evolve, but it wouldn't look like us. It might be a fleeting awareness that forms and dissolves like a dream, or a distributed hive of particles reacting to fields we can't even imagine. Is that life? Is that mind? Or is it something entirely beyond our comprehension? Let's flip the perspective. What if we are the ones living in the oddball galaxy? What if most of the universe actually has very different laws and ours is the exception? There's a principle in cosmology called the Copernican principle. The idea that Earth isn't in a special location. We're not the center of the universe. But what if that principle doesn't apply to physics? What if our galaxy is a rare sanctuary, a cosmic anomaly where the forces aligned just right for long-term stability, chemical richness, and the emergence of intelligent life. We might be the lucky observers, surrounded by a near-infinite expanse of unreachable, unknowable domains where nothing stirs. This perspective radically reframes the Fermi Paradox, the infamous question, where is everybody? If most galaxies have incompatible physics, then intelligent life might only exist in isolated pockets. Even if life arises in other galaxies, it might be locked behind barriers more profound than distance. Communication would be impossible. Technology, if it evolved, might never bridge the physics gap. Each form of life becomes marooned in its own private bubble of reality, forever alone. And yet, there's one more twist. What if it's not just galaxies that differ, but the individuals within them? If the universe allows multiple physical frameworks, then who's to say some beings haven't learned to manipulate or even traverse them? What if a truly advanced civilization doesn't just explore space, but explores laws themselves? Not just starfarers, but lawfarers, beings who sail across realities where physics bends to their will. Are there signs that such travelers have visited us? Would we even recognize their presence if they came from a region of the universe governed by different rules? Or are they out there now watching? Not with eyes, but with senses we can't imagine, operating by principles we have yet to define. If the laws of physics are not universal, if they twist, shift, and reshape themselves across the endless tapestry of galaxies, then what we call reality becomes something far stranger than science has ever dared to imagine. And if that is true, then what does it really mean to understand the universe? Have we been staring through a keyhole, believing it's a window? Let's follow this thread all the way into the abyss. In our current framework, physics is the bedrock. Constants like the speed of light, Planck's constant or the gravitational constant, are assumed to be just that, constant. They define how energy behaves, how particles interact, how matter forms and evolves. But if each galaxy operates under a unique set of these rules, then our understanding is at best local. Physics becomes less like a universal language and more like a dialect, something that only works in our cosmic neighborhood. In such a universe, science itself takes on a new form. Think about how we do science here on Earth. We test, observe, repeat. If something happens twice the same way, we assume it's a rule. But if the underlying physics shifts with distance, if gravity behaves differently 300 million light-years away, then the patterns we observe from here are fundamentally incomplete. The equations that describe falling apples or orbiting moons may not describe the same motion elsewhere. And even worse, the light we see from distant galaxies might already be filtered through those alternate rules, distorting our view without us ever realizing it. We'd be trying to decode a message written in a language we never learned, with symbols that don't follow our grammar. This has staggering implications for one of the most ambitious goals in modern physics, the theory of everything. For decades, physicists have hunted for a single, elegant framework that unites quantum mechanics with general relativity. But if the cosmos is a mosaic of laws, then perhaps no such unifying theory exists, at least not one that fits every piece. The universe wouldn't be a single code to crack, but an ever-expanding library of alien operating systems. And maybe the true task of advanced science isn't to find one truth, but to learn how to translate between many. But here's where things get even stranger, because if the laws of physics can vary between galaxies, could they evolve? Could they change over time? There are real theories, fringe but not without merit, that suggest physical constants might shift as the universe ages. Imagine a universe where gravity was stronger in the early epochs, allowing stars to form more rapidly, but where that force gradually weakened, stretching out time and space, cooling the cosmic soup. If these laws evolve, then so does everything else: life, consciousness, technology. Imagine a civilization that arises under one set of rules, only to watch their world unravel as those rules slowly decay. Now imagine they find a way to stop it, or even leave it. This brings us to a truly mind-bending idea: metaphysics as engineering. What if a civilization could detect changes in physical laws the same way we detect weather patterns? What if they could manipulate the constants, alter, Planck's constant or reshape the geometry of space-time. To us, this would be godlike, not teleportation or time travel, but something deeper, the power to rewrite what is possible. Not just bending the rules, but changing the game board entirely. This isn't just wild speculation. Theoretical physics already flirts with such possibilities in string theory and multiverse models. Some versions of the multiverse propose that each universe bubbles into existence with its own physical constants. But what if those differences aren't just sealed away in isolated universes? What if they exist within our own, just far enough apart that we've never noticed? The cosmos could be more like a fractal, each galaxy a node in an infinite tapestry of realities, each stitched together with invisible seams where physics flexes and adapts. So, how would we even begin to detect such changes? The answer might lie in the behavior of light. Photons traveling from distant galaxies may arrive with subtle distortions, discrepancies in redshift, or anomalies in gravitational lensing. Astronomers have already observed strange phenomena: galaxies moving too quickly, dark matter behaving erratically, light bending in unexpected ways. Could these be signs of physics in flux? Now imagine a future telescope, not just bigger or sharper, but one that can measure the signature of alien physics, one that can map the rules of each galaxy like a cosmic fingerprint. We might find entire regions of the universe where electromagnetism behaves differently. We might locate stars with fusion processes we've never seen, or even, just maybe, we might glimpse evidence of artificial manipulation, structures that bend space-time not according to natural laws, but engineered ones. And what if we are the product of such manipulation? Some physicists have proposed the simulation hypothesis, the idea that our universe could be a program running on some unimaginable substrate. If true, then varying physics could be a sign of multiple simulations running in parallel, each with its own rules, each being tested or observed. What we call galaxies might be simulation environments, labs in which different versions of physics are played out, like cosmic experiments. And in that case, who's watching? Whether or not we live in a simulation, the idea that each galaxy could operate under unique laws raises profound philosophical questions. What is reality? Is it something fixed and universal? Or is it context-dependent, shaped by where and when you exist? Are the truths of science absolute? Or are they local customs of the cosmos, no more universal than language or culture? In the end, maybe we've been asking the wrong question. Maybe instead of, what is the universe made of, we should be asking, which universe are we in today? Because if the cosmos is a patchwork of laws, then we're not explorers of space, we're explorers of possibility. Each galaxy becomes a new page in an ever-changing story, a grand epic written in 1,000 different tongues, and maybe, just maybe, one day we'll learn to speak them all. If this journey through the multiverse of physics made you think differently, if it sparked a new question or a wild idea, let us know. Leave a comment, share this video with your fellow cosmic thinkers, and give it a like if you want to see more deep dives into the unknown. Because here at Cosmic Whispers, we don't just look at the stars, we ask what they're really made of. So Tella, if you could visit a galaxy with completely different laws of physics, would you go? And what do you think you'd find?